let's move past the very dramatic thumbnail and discuss why we're doing this. So we already have benchmarks in the chatbot arena, which are great for judging the general capabilities of these models. But we may want a way to run a specific set of tasks that's specific to us or our workflow, and see which large language model is best. So to that effect, we came up with a pretty short Python script that works in two stages, basically. So the first stage is to generate answers or responses to the tasks that are broken up by category. The second step is to judge these answers or pick favorites from them and save the results to a CSV. So this is just another view of the script itself. Again, we see these tasks are fed into these prompt templates, which in essence just tries to get a specific type of response, a specific style of response from the API, mainly eliciting a chain of thought style response and formatting it in a way that it's easily parsable. So those results are saved in the responses.csv. Now we follow a similar process for the second step. The difference here is we have two responses to feed in, so we give it both orders to see if that matters. So the two main inputs are the tasks and the templates. The tasks, these I came up with relatively quickly. They're short, mainly focused on math, computing, and education. These categories are a bit unbalanced. The expository, by and large, has the most questions in it. So I'll briefly go over the categories here. We have open-ended questions, create a syllabus, create a quick start guide, come up with multiple choice ideas, not actually create the questions, but what kind of ideas, what kind of questions could we ask about this subject, and then difficult mathematical reasoning and Python coding problems. So for the templates, we covered them. Mainly, we're using them to get chain of thought style responses and to get answers in a particular format. I tried two different versions of these. The first is kind of like more natural, what I came up with in the first place. And then the second template was just always putting the prompt at the very end for the get answer. Obviously, they need the prompt to answer the task or to respond to the task. And for the pick favorite, the judges need to know what prompt that these models are trying to respond to. So it sees the candidate answers first and then the tasks later. All right, let's take a look at the results. So we see for both versions of the prompt template, GPT4 takes it, but not by a huge margin. This is kind of similar to what we see on the chatbot leaderboard. I mean, there's no direct comparison, but we see GPT4 ahead of Claude3 Opus. So there's some agreement there. And then when we look by judge, we see, maybe surprisingly, there's pretty good agreement between the two models. So when Opus was a judge, it picked GPT4 as the winner. And same thing for GPT4, and that repeats across versions of the prompt template. So now we could look at the results broken down by category. So we do see some sensitivity to the kind of way the prompt is structured. Just putting the prompt at the end kind of changes things. What's constant between them is GPT4 seems better at these expository type tasks, and Opus seems better at syllabuses. So with the different prompt orderings, we can check if they were consistent, like if they always picked, if GPT4, say, picked Opus as the winner when Opus was in the first slot. If we switch the ordering and Opus was in the second slot, did it also pick it again? So for this specific comparison, there was not, I would say, not great consistency. I was a little disappointed by this, but I tried a couple more pairings. So I ran a few more experiments, and I saw for these other models there was a lot better kind of separation, a lot more consistency. So I'm not sure exactly what's causing this. I mean, it could be A, B, or maybe something else being, they may be very close in quality, so it's kind of hard to pick. Anyway, and maybe humans would have a hard time doing that too. Or maybe the response quality is so good that it makes it kind of difficult to distinguish what the best response is, at least for these models. I'm not sure. It could be both. It could be something completely different. So the takeaways, this was obviously a very small um, kind of study, I guess. I don't know what to call it, but a short experiment. Um, Take everything I say about this with a grain of salt, and of course the code will be available on GitHub, so you could run the experiment for yourself. You don't have to take my word for it. So overall, GPT-4 seems a bit better. Um, the models don't seem to be self-preferential. As we saw earlier, you can have Claude 3 Opus picking GPT-4 as a winner, and in fact, for these other comparisons, that held true as well. So yeah, there was some sensitivity to the way the prompt was organized, so just be careful with that or experiment with that a bit. We already discussed what may be causing that inconsistency in judging between Claude Opus and GPT-4. So another takeaway, at least for me, I'm not sure if how many people are actually going to do this, but if you could have a short task list that you could use as a test set to evaluate new models, especially if you use these in production. But even testing against different versions of APIs, it's probably useful. So just to make sure uh, they behave the way that you expect them to behave on the tasks you use or the tasks you run quite often with these large language models. This is more important for people who use the API, not so much for people who just use the chat interface. Um, Also, as we saw with the expository and kind of syllabus differential, these different model providers may be suited to different problem domains. And I actually suspect that this is due to the training data rather than uh, anything else. So I didn't show it, but when I ran Haiku versus GPT-4, which Haiku is Anthropic's smallest model, GPT-4 barely beat Haiku on syllabus design. Again, Claude Sonnet destroyed GPT 3.5, which you would expect, but specifically on the syllabus design, it blew it out of the water. So um, yeah, just be aware of that. And yeah, the more niche your problem domain is or specific your task, the more likely you're going to want to be to experiment with these. Otherwise, you could kind of rely on the benchmarks or the chatbot arena to kind of guide you there. Um, Cost-wise, Opus is way more expensive than GPT-4. So I would experiment with Opus specifically if you really care about the quality and output and a little bit of difference in quality means a lot to you, then it may be worth paying the premium if you discover that Opus is better. But just keep in mind it's something you could try. But if you want to be, I guess, economical, GPT-4 is better if you're looking for high quality output at a better price. Rate limits, just be aware when you're running these experiments. Both of these providers require you to purchase some credits and wait, I think, 7 days before like you could run a lot of requests per minute or tokens per minute. You could check their respective pages for more info on that. But Anthropic in general has more restrictive rates. Um, yeah, if you try to use Google too, there's some code in there to generate responses for Google as well, but their rate limits were way too restricted for me to run the experiment with them. Um, so stuff you could try. The code is available on GitHub. Again, it's short 360 lines of Python with the only other stuff there is the input folder, the output folder, and there's a logging module there as well. But you don't have to touch that. It's pretty easy to modify. I do have some instructions for there on there for how to modify the code to do some um, tasks I would expect that people would want to use it for. But of course, you could modify that beyond that as well. So yeah, just some stuff you could try. I recommend trying tasks within your problem domain. This is probably the biggest takeaway I would say. Um, yeah, you could obviously try varying the prompts using tricks like some emotional blackmail, telling it your grandma's gonna fall down, I don't know, a flight of stairs if it gets the answer wrong. I haven't tried any of that, but some people have. They tried the tipping thing. I don't know how well it works, but in any sense, when you do vary your prompts, be aware of tokenization. Andre Karpathy has a great like lecture on it. It's kind of long, but if you want kind of a shorter visualization for what goes on and how your text is tokenized before it's fed into these LLMs, check out the Tick Tokenizer app. I'll leave a link so people could check that out. Um, yeah, you could try different model providers. Obviously, I mentioned Google's rate limits being very restrictive right now. Um, I'm sure with Llama 3 being released, there'll be some APIs you could try for that too. That seems very promising. Um, I mentioned this earlier as well, split testing different API versions. Uh, I've yet to try it, but I probably will on later releases of GPT-4. And then you can try, you can get fancy with the message structure. You can try completing part of the response for the LLM and seeing if you get a response that you like better. And you could try that with, multiple models. So if you guys are curious what I'm working on something called learngood.com. Uh, Pretty much right now we have large question banks for Google Cloud certifications and other programming topics. So pretty much we're trying to create educational material with these large language models. Right now, all of them are manually reviewed before they're being published. Most of the stuff that was on there is free. If you want to check it out, you can even try it without signing up. So that's cool. So yeah, what I'll be doing there is just experimenting with the multiple choice generation pipeline, which is it's a pretty interesting problem. It's fun to see how to do that the best way possible. Um, we can take a look at the code now, real quick. Just to show you guys, it's not that scary. Um, there's a pretty kind of dumb way, I guess, or simple way to put in your API keys. If you have them as environment variables, it'll grab them as long as they're named the same way. Otherwise, if you're not committing to a repo, you could feel free to just plop them in there uh, to get it running. Let's see, we got just some helper functions here. Um, these are the functions to generate the responses for the different providers. Just some regex parsing here. Here's the templates which come from here. So you could see the difference that I was discussing earlier in how the prompt is structured. The tasks, pretty easy to modify right there. All right, yeah, so now we see step one. This is kind of like the inner processing function that gets uh, processed with a semaphore, so we could run a bunch of concurrent tests at once. So we're not waiting for everything to, one response to come back and then now ask for the next one. I know OpenAI just came out with a new way to batch these, which I haven't played with. Um, And yeah, and then we have the second step. So again, similar, we have the inner function kind of that's run with the semaphore. Uh, yeah, uh, yeah, just be aware of your rate limits. If you have really low rate limits, if you set this to 1, it's pretty much just going to run in a linear fashion. If you have high rate limits, you could, put it to 5, 10, 20, 100. I just depends on your rate limits. So you're going to have to figure that out. All right. Um, thank you for sticking around. Hope you get some use out of this. Thank you.